So now everybody's been fueled with caffeine and cookies and to talk about air quality. So that's good. It'll be a lively session, I'm sure. And then they've also called a timeout to ice the kicker. So we'll see how we do here. My name's Dave Randall. I work with Air Sciences Inc. in Golden, Colorado, and we are about 40 scientists and engineers that do technical and regulatory air quality work for industry and government clients. My role in this project, Air Sciences has been retained as a independent third-party reviewer of the air quality modeling analyses that are being prepared for the environmental assessment. The crew at Air Sciences, including dispersion models and atmospheric meteorologists and principal reviewers like myself, are charged with taking a look at the various plans and modeling analyses and inputs. We'll talk about a little bit more for the air quality assessments. I'm very pleased to be back in Kamloops to talk about air quality issues with regards to this project. I was at the open house sessions earlier this year and had a lot of very lively and discussions with informed folks about the air quality issues associated with projects such as this, so I'm happy to be back to talk a little bit more about them. My purpose in this presentation is to describe for you all the air quality dispersion modeling process, the tools that are going to be used, how we've kind of got to the place there where we are now, and then have an opportunity to hopefully answer some questions, and if not, to take your input on if you have questions about the air quality dispersion process when we're done. Before we kind of roll into the slides, just to give an overall picture of where I think this air quality dispersion analysis fits in. The ambient air quality objectives set by the province, the Ministry of Environment, kind of set the stage for establishing what the health-based air quality criteria are. Once those rules and those standards are in place, there's a process of information gathering and data collection to characterize existing air quality, to characterize the emission sources at a proposed project like the Ajax Mine. And then we enter the assessment phase, which is where the air quality dispersion models come in. And that's what I'll describe here in a minute. And that information, the results that come out of the air quality dispersion models, which we don't have yet, but are being worked on, that becomes the information used to support decision makers, whether it's regulators about permitting or whether it's the mining operations and processing folks about air pollution control, whether it's purely for the purpose of disclosure to the public during this environmental assessment process. The model results inform all those decisions. So that's what I'm about to talk about is how that information to support those decisions is developed. I'll quickly introduce. I've kind of covered mostly what I want to talk about with the introduction, but we'll get into the model plan that's been developed to describe how this work is going to get done. I'll identify the dispersion model that's been selected for this assessment. Talk briefly about the kinds of emission sources that will be evaluated, the substances of, boy, when I turn, that really makes a big difference, doesn't it? So I'm in an awkward place to look at that, so I'm going to move over here. I'll talk about the substances of interest that are going to be evaluated. We'll take a look at what the modeling domain is for CalPUF and some of the special features, unique features that will go into the CalPUF modeling to support the human health and ecological risk assessment. And then finish up by talking about the kind of QA, QC procedures that will be a part of the modeling analysis as well as an official role that Air Sciences will take in reviewing the analysis that's done and what we expect the final assessment report to look like. So the air quality assessment is an integral part of the Ajax Mine environmental assessment. Ajax has retained a team, including Stantec Consulting. They're going to prepare, they've already prepared the detailed dispersion modeling plan, and they'll do the heavy lifting when it comes to performing the modeling analysis. And Air Sciences has been retained, as I mentioned, to perform an independent third-party review and to serve as an advisor to Ajax and Stantec. We've been involved in similar types of projects, hard rock mining projects located in not so remote areas, and have evaluated or performed these models ourselves. So we're pretty well versed in the subject matter, and confident that we could add to the quality of the analysis that's ultimately done. The computer-based atmospheric dispersion modeling is the mathematical simulation of how air pollutants disperse in the atmosphere. That's sort of the general description of what it is. It follows very similarly, I've been listening to all the other presentations today, it follows very similarly the logic. You do your best to characterize the existing conditions. You learn as much as you can about the potential source of whether it's changes to water quality or water quantity or vibration. You use these simulated mathematical programs to figure out as best you can what the downstream impacts are going to be. And then you use the model to test what kinds of mitigation and controls are necessary to demonstrate that whether it's a threshold of concern or an ambient air quality objective, a water quality objective, whatever it may be, will be met. So the logic is really the same here with the CalPUF modeling analysis. So these models are used to estimate downwind concentrations of airborne substances emitted from sources such as industrial plants, not exclusively, but that's most germane to this conversation tonight. And among other applications, the results of these models are used to support decision-making pertaining to the levels of air pollution control necessary to demonstrate that an existing or a proposed facility will comply with applicable air quality standards, and to inform the decisions ultimately of whether or not air quality permits will be issued and what sort of conditions to control air quality or monitor air quality will be included in them. The jumping off point for the assessment was the preparation of a model plan, and a detailed dispersion modeling plan has been developed by Stantec, has undergone our review, and has been approved by the BC Ministry of Environment. Now, that plan was developed in consultation with the Environmental Assessment Working Group, with Ajax project staff, including engineering and operations and environmental, and it's considered, it's been developed considering written stakeholder input provided by the BC Centre for Disease Control, the City of Kamloops, the Interior Health Authority, and CAPA. So the process has been relatively open, and the specifics in the modeling plan have been shaped by the input of these organizations. Now, in the preparation of the modeling plan and in the setup of the model, all aspects of the model inputs and the setup are evaluated for consistency with the BC Minister of Environment modeling guidelines. I mean, that's why they're there, and that's how you facilitate effective review and a complete modeling analysis, is paying attention to these guidelines. Now, at the end of the day, the goal for how the model is set up and what the inputs are that feed the model is to adhere to the plan that's been written to be consistent with the guidelines, and to prepare model simulations that are likely to be representative of the conditions at the project. it's important because we're informing decisions downstream. It's important that there's some element of realism that's being built into these models. Now, if you're consistent with the guidelines and you employ these models the way that they're designed to be employed, there is certainly some level of conservatism that's built into these model algorithms. We typically expect model results to be higher than ultimately air quality impacts will be from a facility. And certainly for mining projects that I've worked on, that's borne out when we've done the analyses ahead of time to support these decisions for permitting and air pollution control. And then those permits are issued and those controls are implemented, and we do post-construction and operational monitoring. The air quality concentrations at the points of maximum impact around the facility are typically less than what we've modeled. So the process is designed to give confidence in the results by having conservatism built into the procedures, as well as representing the project as closely as you can to what you would expect in reality. Now, the modeling tool that's going to be used for this project is called CalPUF. I'm sure that's a long-winded acronym, but I don't know what it is. It's the BC MOE recommended core refined model for this type of assessment. There are others, but CalPUF is an appropriate one for several technical reasons that are described in the plan. And core models as defined by the Ministry of Environment are those recommended by the U.S. Environmental Protection Agencies, and they're also referred to as regulatory models in that they can be used to estimate the impacts due to emissions from sources and compare those to applicable air quality standards, such as the air quality objectives. There's three components to the CalPUF modeling system. I'll just cover them quickly. There's, whoops, sorry, that's not the clicker. There's CalMet, which is essentially the processor that builds the three-dimensional meteorological data set that tells the model where to push emissions. There's CalPUF that actually does the algorithms to figure out where the emissions are going to go and what the concentrations are going to be, and deals with chemical transformation and dry particle deposition and a whole lot of flags depending on the application of the model. And then CalPost is just a way to make sense of all the results that are generated by CalPUF. It helps to organize the data, apply it to some projects have specific applications that the CalPUF model results can be used to, and CalPost helps you do that. The important inputs to CalPUF, I heard one of the folks that answered the question today say that the models are only as good as the inputs. Well, that is absolutely the case. CalMet provides the meteorological data. There's a considerable amount of information about the emission sources that goes into the modeling setup, including location, elevations, emission rates, and source characteristics like the exhaust velocity coming out of a stack, or the temperature and buoyancy of an emission source. All that goes into the CalPUF model to instruct the algorithms on how to treat those emissions. You also load it with digital terrain and land cover information so that you're characterizing the site, changes in topography and land cover, and then you overlay locations of receptors of interest so that you cover the geographic area and the areas of special interest that you want modeling results for. This figure depicts the modeling grid for this analysis. It's a approximately 25 kilometer by 25 kilometer grid centered on the project. And you'll notice that as the distance increases from the center of the project, the density of the receptors in the modeling grids gets larger. So more refinement of the modeling results close to the boundary, but still information on a reasonably dense grid as you get further away from the project. Like a lot of, like some of the other environmental media that were talked about today, like vibration, for example, distance from the source is a very important input for the air quality impacts from that source. So it kind of makes sense that you would want more refined information closer to the source, but still, a sufficient density grid to give you results that are within the precision of the model at more distant receptors. 2 emission scenarios are going to be evaluated. One is during the construction phase, where there'll be considerable surface disturbance and material movement, and one during the maximum year, and that'll be defined in the mine plan as the worst case year for mining operations based on the evaluation of maximum levels of emissions, of mining activity, of source locations relative to the project boundary, and that is a specific answer, and it depends on the mine plan, which is once that's defined, then the analysis goes into choosing what the maximum year is going to be, and that's what will be evaluated. A quick look at the emission sources to be considered. You've heard them mentioned a couple of times with other presentations. The in-pit sources, mobile equipment, burning diesel fuel, in-pit sources, moving material, loading it into trucks, hauling over haul roads, putting ore into the crusher and the conveyance system to get processed, moving overburden to the overburden storage facilities, and then also the tailings storage facility as one of the byproducts of the process plant. So the emissions from all these sources are estimated. The controls that are planned, like this, for example, this diagram shows covered stockpiles and water sprays on hoppers and water control for haul roads. All those are incorporated into the emission inputs that go into the model. The substances of interest to be included in the assessment include total dust fall and several types of particulate matter, total suspended particulate matter, TSP, and 2 smaller size fractions of particulate matter, PM10, which is sometimes called inhalable particulate matter, and PM2.5, which is sometimes called respirable particulate matter, sulfur dioxide, oxides of nitrogen, carbon monoxide for the combustion emissions from the project. And in addition, I'll talk a little bit about this more in a minute, but for the human health and ecological risk assessment, potential contaminants including metals contained in dust and polycyclic aromatic hydrocarbons contained in diesel will be included to support the HERA analysis. I mentioned the domain is 25 by 25, and so the key to that sizing is that the guidelines say that your receptor grid should be far enough out that that all your predicted concentrations greater than 10% of the applicable air quality objective are contained within the domain. So you don't want to stop so close that you still have high impacts that are just outside of the domain. You want to model out so that truly the impacts that are at the fringes are less than 10% of the applicable ambient air quality objective. And the size of the modeling domain in this case is expected to be sufficiently large to satisfy that recommendation in the guidelines. This is an aerial photo of the Kamloops, Aberdeen project area. Shown in blue is the project area, some features like roads and Jacko Lake shown in yellow. The limit to the City of Kamloops development boundary is shown there, and the extent of the modeling grid is shown there in red. As I mentioned, CalPUF will also be used to support, the results will be used to support the HERA analysis. It'll include the list of metals and other chemical species that I just mentioned, and it'll include, coming up on 200 or so special receptors of interests, similar to the other presentations, elementary schools, hospitals, daycare facility, retirement homes, areas of sensitive members of the population where it's important to specifically look at the health effects associated with emissions from the project. There's a map that depicts the location of those 200 some odd special receptors for the HERA assessment. A couple things that we're going to do to try to not only have high confidence in the quality of the inputs to the model, but also to evaluate the performance of the model. There's QA/QC procedures that are identified in the plan and that we'll take on as our third-party review to confirm the accuracy of all the source inputs, the receptors. The metadata has already been evaluated for its representativeness of the project, the metadata that comes out of CalMet that was provided by the BC Ministry of Environment. But all that work gets reviewed as part of the QA/QC review process. The input and output files we'll review internally, and those, by the way, are going to be part of the public record. They will be submitted, including the executables. So the idea behind air quality modeling is that once you do your work, the inputs, the outputs, the executable files, everything is provided and part of the public domain so that the process is as transparent and as repeatable as you can make it. The outputs will be examined for consistency with expectations based on experience with other similar application of dispersion models, and we'll have documented technical reviews by folks within Stantec and my shop, from folks not necessarily involved with the day-to-day work on the project to give it a fresh look. And then the report that will capture the air quality modeling work will it'll cover the existing environment. It'll identify why these pollutants were selected as substances of interest versus others. It'll give a full description of the dispersion modeling that's been done to set up for the project. It'll display the results and provide a discussion of the interpretation of the results. We'll include a talk about the precision and uncertainty of the modeling results, and then present the findings and the summaries and conclusions of what the dispersion modeling analysis tells us, and provide that information to the folks that need it to support their decisions downstream. There'll also be a series of appendices. This may not be a complete list, but it's a shot at it for now. And again, that's all the technical support that will be available for the regulatory agencies and the other decision support, the other folks that are making decisions to repeat results and scrutinize the modeling inputs. So I think that's it. Hope I didn't talk too fast, and be happy to take on some questions about the dispersion modeling process and jot down anything that the group would like to say.
Thanks, Dave. That was great timing. So we are ready for our question period.
You've stated that you've done some work already and you've been in town in the past. And how would you characterize the existing air quality in Kamloops pre-mine?
I've been here for a few days in the winter and got in here at about midnight last night, so I'm no expert. I've just to do my homework, I've read something about the existing air quality information and some of the historic issues with air quality. I know it's a unique place because of the situation with river drainage and the wintertime inversions that happen. The winds are unique here. I've looked at the inputs to the AirMet meteorological data set to see, whether or not it seems to be capturing some of those unique characteristics, and we think so. And it was cold. It was cold when I was here last time. I do know that. My personal experience is very limited, but I'm pretty aware that we've got the right type of meteorological data and air quality data to support the characterization of the current environment going into this assessment.
So is there data available on, let's say, the emissions from the dump that exists today, or the coal dust that comes off trains already? Is that sort of data available already?
I guess it's not within my purview to know that. The Ministry of the Environment, I'm sure, their web page is exhaustive. They have lots of links to existing air quality data. I'm sure they have emission inventories for sources that impact air quality. So I imagine the data is out there. I have not looked at it.
Okay. I guess it's just my hope that folks aren't expecting a much higher level of a standard out of the mine than that they tolerate every day in their everyday lives. I know in certain months, spring and the fall, and I look across the Thompson River, when the wind's blowing by the dump, you can't see from one side of the river to the other. So, I think we have to sort of bear in mind what the existing situation is already. Anyways, that's my comments.
Thank you.
I have two questions, and they may not be very clear. Some of us had understood that all the meteorological data had come from one place. Is that still true? That one piece of machinery on the lee of a mountain?
No, and specifically for the meteorological data set that is generated by CalMet, one of the modules in CalPUF, none of the meteorological data that is supporting this modeling effort comes from a single station.
Okay, so because that was information we had quite some time ago, so I was just concerned
that's not accurate. The CalMet metadata sets are fed by numerous meteorological data sets that was developed by Ministry of Environment, and we'll certainly, the report will document the sources of the meteorological data, but it's not a single station that's on the site.
Okay, thank you. My second question refers to the dispersion modeling software that was used, and you said it's already been approved by the Ministry of Environment. Is that the most recent version of the software? Because we had been told they were using an older version and had chosen not to use a newer version, and we're wondering why not, and could they consider using it?
I will make a note of that concern. These models certainly do evolve as there are bugs that are worked out or there are new features that are added. And typically it's the standard of the regulators that at the time the modeling analysis is done, the most recent version is used. There may be some features from one version to another that make a prior version useful to consider. But I would expect the latest version of the model to be used, but I'll note down the concern.
Are you still using high atmospheric measurements from Kelowna to be inputted into the model?
Let's see. I don't know the answer to that question because I'm not actually doing the CalPUF modeling. That's being done by Stantec, but I will certainly, I could find the answer to that question and provide it, but I do not know the answer to that question.
We've been told that that's where the high atmospheric measurements have been taken, so no high atmospheric measurements from Kamloops have been done to our knowledge. So therefore, would you say if that is true, that would therefore limit the model in terms of its predictions and the accuracy of the model?
I can speak to my general experience with acquiring the inputs associated with running CalPUF or AirMod, these regulatory models, it can be a juggling act. And there are lots of, for example, in the United States, there's lots of National Weather Service weather stations that supply very good ground level data. There are comparatively very few high atmospheric condition weather stations. So as part of the modeling plan, you identify the data sets that are available, and you provide the technical justification to choose one or another, because you have to have it. And then the agency, the dispersion modelers in the agency, they either agree with your selection of the upper air data or they do not. What's also true is I have not run into a situation where the locale that we were modeling didn't have high atmospheric data, and it was a requirement to collect it before the modeling was proceeded. The option was always to find a representative data set rather than to require the collection of new data.
You don't think it would be reasonable to require the measurement here in Kamloops, given the fact our population is 90,000 people and the mine is almost within, well, it is partially within city limits?
What I will do, I've noted down the question, and I will certainly look at the...
But you're an expert in modeling, so I guess I'm asking you, do you not think that if you were living in Kamloops, you would want that? That's my question.
And I don't know the answer to your question. I do know that high altitude data from distant locations, even from populated areas of concern, have been used in models, and the models have performed well. And I would suspect the Ministry of Environment to have the same expectation in this case.
What is the grid size that's being used in the model? Because the last time we looked, the grid size was actually quite large and looked like it was going to miss a lot of geographical data that would be important. I couldn't see the grid size on your slide, which is why I'm asking.
Yeah, by grid size, do you mean spacing?
Yeah, the size of your grids.
Well, I don't remember the numbers off the top of my head, what the spacing is. I know that it gets less dense with distance from the project. By the look of this modeling grid, without knowing the specifics on the top of my head, it seems like the terrain features within the modeling terrain and how the model uses them would be adequately captured by characterizing those features at all the grid points that are identified on that figure. And the plan with that grid has been approved.
How many sites have they actually done measurements of the chemical composition of the air in Kamloops?
I don't know specifically. I know that they're not related to this project, but there is existing air quality sites in the valley to characterize air quality.
I know there's one or two in the valley, but have they done any in Aberdeen where they've actually looked at the chemistry of the air?
I know there's filter-based PM 2.5 monitoring in the project area. I don't know whether they've done chemical analyses on that particular.
I don't think they
know the
have.
answer.
Thank you.
Thank you. Next question.
I was wondering why the BC air quality standard of 6 isn't being utilized as part of the proposal. Instead, it's 8 to 10. And we're already customarily in Kamloops 10 and over. And these numbers are rather hard to interpret as the average population because they're a rolling average. So at any one date, we'll have numbers as high as 25 and averaging off with as low as 2. So do you have a dispersion model that accounts for that degree of variability?
I presume you're talking about PM 2.5?
Yes.
Let's see, there were several questions in there. The applicable air quality standards will be used to compare the impacts to, whatever those are at the time. And I know that there's been new standards recently promulgated. And does the model account for variability in air pollution concentrations, even for rolling averages? The answer to that question is yes. Because air quality standards not only have a numeric value, they also have an averaging period. It could be 1 hour, it can be 8 hour, and there's a statistical aspect to it too. It could be the second high or the 98th percentile. And the post-processing routines in CalPUF allow the data that is generated by the model to be appropriately processed to provide the results to compare directly to these statistical standards. So yeah, the model is capable of looking at that kind of variability, and the outputs from CalPUF are spatially and temporally specific. So you know where it happened and you know when it happened. If you know when it happened, then you know about the meteorological conditions that caused that particular impact that you're interested in.
Okay. Question on the grid. We have a funnel effect to our valley, and that's not included in your grid. So along the same lines as the noise dispersion modeling that we've heard earlier tonight, how does CalPUF account for katabatic wind and the wind effects and funneling to our valleys? Number 2 is CalPUF is a model that has been developed for level land assessment rather than for elevations. And I was curious as to whether you will be modifying CalPUF or taking real data instead of extrapolating.
Let's see, the 2 questions there, I think. The meteorological data set is a 3-dimensional data set that does account for terrain, and you can analyze the wind fields with expected or observed data to see how well CalMet did in producing that CalMet data set. And that's been done as part of the modeling plan review and as part of the ministry's review. So to the extent that there are inversions, that there are katabatic winds, that there are predominant winds in one direction or another, the data set has been tested to indicate that it's performing as we would expect it to. If there are other specific parameters that we should look at also, that can certainly be part of the QA/QC review that is done. Second question, I don't think it's an accurate statement that CalPUF was specifically designed for level land. Its first use was for long-range transport, like over 50 kilometers away from a source. Certainly incorporated changes in elevation between the source type and the impacted areas. And the inputs from CalPUF include three-dimensional grids and terrain effects. And all these models are simulations. You know, it may not, you have to assess whether the performance is reasonable for the kinds of answers that you're getting. But terrain effects are certainly part of the CalPUF modeling system.
Okay, and the last thing is the 2003 summer that we had with our fires is being used as the worst case scenario. Having lived through those, having to suggest to my patients that they exercise inside the tournament capital center so the air would be filtrated before it hit their lungs, I have concern that that is our base.
And pardon me, but the base for?
For worst case scenario for the mine functioning. And I believe that was in their air, and so I'm looking at their direct information on that.
Let's see. The process of assessing the cumulative impacts from a project such as this would include recognizing that there's a background level of pollution and impacts from other sources. And you could also analyze for when there are exceptional events like wildfires or dust storms or other types of maybe uncontrollable events, but that still affect air quality. It would be, I'll have to look back at the plan, it would be a very unusual methodology that would use the highest possible impacts from an exceptional event as kind of the standard bearer for the conditions to assess. You might look at it to bracket your decisions. The worst case background conditions might be this, more typical might be this, so that you can inform the decision makers will have good information to inform their actions accordingly. But I will certainly look to see how 2003 fire season impacts the background concentrations.
Great, thanks. Next question.
Thanks. I have a two-part question, and I didn't understand the chart that you had up, and I think you mentioned something about more than 200 receptors. What was that chart, and what did that mean?
Oh, I think was it. I think it was.
Yeah, that. No, go back.
This one?
No, yeah, but the map.
The map.
It's right there.
This map shows the special receptors of interest that were added to the modeling grid to support the human health and ecological risk assessment. So the dots that are on this map are the locations of the facilities listed on this list.
Oh, so other facilities, in other words, that could be creating something.
No. Places where we are uniquely interested in what the air quality impacts due to emissions from the mine.
I see, okay, because I thought by receptors you meant that they were spots where, in other words, they were test sites of testing the air, but...
no, they're locations of interest that may not have been captured in the grid.
Right,
There
I
are
see.
specific locations of interest to be considered in the HERA analysis.
Okay, thanks. My other point dealt with actually the previous question, and that is cumulative effects. I'm sure that in your studies you're aware that we have Lafarge cement just down the way, and when the wind comes from there, we have problems there. And of course, with the new low stacks in town, we have problems again from our pulp mill. And the gentleman over here mentioned the fact that there are days you can't see across the river. Now, all of that's taken into consideration in what you're doing when you're dealing with air quality. Is that correct?
The use of existing background information and on occasion the use of modeling contribution from other sources is ways that, that those kinds of situations are assessed in the model. Certainly background concentrations that include impacts from existing sources will be a part of this analysis. I would have to look back at the modeling plan to see if there is a competing source analysis that goes along with it. But the selection of the background data set that adequately captures the pollution that exists due to existing sources is an important part of selecting the background concentrations that go into the model.
Right, it's very important, and actually you need the really newest information, because in my neighborhood we went from 31 tons to 81 tons of pollution a year from the pulp mill because they put too low stacks in, and that happened in 2013. So I'd like you to be sure that in fact your latest data on that, and of course being downtown we're not going to be as affected as Aberdeen, but you add any more pollution to what we're already breathing and we're in trouble. So I appreciate it. Thank you very much. And thanks for your presentation.
You're welcome. Thanks.
Thank you. Next question.
So just in regards to those HERA sites that you showed on the map, and there being special receptors, what are you going to be measuring at those sites?
Measuring nothing. We'll be modeling impacts at these sites.
So you're just modeling again?
Correct.
So you're not actually measuring anything?
These are just receptors added to the modeling grid to get the data specific to these locations. That's correct.
So how many sites in Kamloops, because the model's all built on measurements. That's your bedrock of your model, is your measurements. How many sites are you actually taking measurements from? Real measurements?
Let's see. The data that comes from measurements that are used in CalPUF are to characterize the meteorology, so weather data, and to characterize background concentrations. And it's my understanding that maybe 4 local meteorological weather stations were used to inform the three-dimensional MET data set that the Ministry of Environment provided. And I would have to refresh my memory to figure out what the background concentrations are. So existing data informs those things in terms of measurements.
Great, thanks. Is there one more question that we can finish up on?
Models are great things for producing tables to 3 or 5 significant figures and contour maps with all sorts of wiggles on them. But what typically is missing from the reports is any statement of the calculated uncertainty in any of the values. And that depends not just on the inputs, but as I said before, on how you deal with what you put in and also what you leave out. And I want to read you one sentence written by the air quality meteorologist in Kamloops to the BC Environmental Assessment Office. It says, "Given the large uncertainties in the emission factors for fugitive dust and other particulate matter, there is little utility in decreasing grid size below 250 meters, as it will not supply more information." So he's saying the emission factors are crap, and therefore there's no point in making the model more precise on the ground. So my question is, as a third-party assessor, will you guarantee that all the model results will come with a specific uncertainty that's calculated for each value?
I'll answer that question no, because the sheer volume of model results that are produced by CalPUF would make a specific uncertainty kind of a pointless and very laborious exercise. What I will commit to, and I think I included it in the quality review slide, is that the assessment report will include a discussion of uncertainty and the parameters that are most uncertain in the model, and that may be the emission factors, it may be the meteorological data set, it may be something else.
But we need to know what the uncertainty is in the calculated values on which the decisions are going to be made.
Right.
So if Stantec says that the worst case scenario for PM 2.5 emission 14 years from now is 16 grams per second, we need to know, is that plus or minus a factor of 2 or 3 or 5? How well are they actually able to predict 24 years from now or whenever it is, that value? Not just run off and say, oh, it's 16. And so somebody, you or somebody, has to tell us what that level of uncertainty is.
It's a very reasonable expectation to have uncertainty documented in an assessment like this, and especially on the key numbers that are used by the decision makers. And I've taken a note of it, and uncertainty will be addressed. And I think I mentioned it in my talk. You're absolutely right that modeling results for any medium are uncertain and have a certain amount of, and there's imprecision and uncertainty, and there's a difference. And you've got to know what those are in order to use the data to make decisions. In the case of these air quality dispersion models, it's right that you can swim around in the weeds to get more resolution on something that really doesn't end up mattering much because of the uncertainties elsewhere in the model. But it's also right that model performance typically demonstrates that the model results are conservative. They predict higher than what you would normally expect. So one of the ways to put the uncertainty into context is to also assess the level of conservatism that's built into the model. And just in terms of how you retain your confidence in the results to make decisions from them.
One of the implications of that, though, is when you're modeling things that aren't being measured down the road, then the only thing you have to go on is the model calculation. And then you need to know, is it really any good, or is it just a guess, or, you know, where are we at with it?
Yeah, fair enough.
Great, thank you. So we'll invite the next presenter up, Brian, our last presenter. And while he's coming up, I'll just remind you all again that any questions that we don't get the opportunity to have you personally address to the presenter, please write them down or use the website or phone the office. They are of value to the process.